IB students, can you predict how the parameter k changes the solution? First, we write these equations as an augmented matrix. First row of the matrix is 1, 2, negative 1, 6, 2, 4, k, and 12. Let's eliminate the first variable in the second row. It is the same as eliminate x from the second row. How do we write the row operation here? Row 1 multiplied by negative 2, add to row 2, new row 2. Multiply all entries in row 1 by negative 2, negative 2, negative 4, 2, and negative 12. Then copy row 2 below. 2, 4, k, 12. If we add them, 0, 0, k plus 2, 0. Student, you might want to present this step on its own for clarity. After this step, the new matrix is 1, 2, negative 1, 6. Row 1 stays the same. Only row 2 changes. Row 2 is 0, 0, k plus 2, 0. Alright, so we have completed the row operations, and now our matrix is in a form that is ready for interpretation. This is the key turning point because from here, the matrix will tell us exactly what happens geometrically between the two planes. The big question is, do the planes coincide or do they intersect along a line? That depends entirely on the value of k. So in part 2, we will analyze the possible k values and identify each case clearly. So click on part 2 to continue. Look at these matrices. Can you figure out the type of solutions? What happens if k plus 2 is 0? So if k is minus 2, row 2 becomes 0, 0, 0, 0. Can you figure out, is the solution a line, a plane, or no solution? The solution is a plane because the planes are coincident. Also, we often call this case infinitely many solution. So, this is one type of solution. Are there any other possibilities, students? Second case, if k plus 2 is not 0. If k plus 2 is not 0, that means when k is not negative 2, this means k can take any value except minus 2. The second row of the matrix is 0, 0, k plus 2, and 0. Please take note, k plus 2 cannot be given a specific value. IB student, can you recognize which case this is? it is 0, 0, m, n case. In this case, the two planes intersect at a line. So let's go back to our matrix 1, 2, negative 1, 6, 0, 0, k plus 2, 0. Can you find the equation of the line? Look at the second row. The equation is 0x plus 0y plus k plus 2z equal 0. No matter what value k takes except minus 2, the z coordinate is always 0. I repeat, knowing that k plus 2 is not 0, z is always 0. Back to first row of the matrix. Can you write the equation that connects x and y? The equation is x plus 2y plus negative 1 times 0 is 6. X plus 2y is 6. Student, do you know what am I doing now? I am trying to find the equation of a line when k plus 2 is not 0. Come back, please. I know some of you might be feeling lost. Let us continue. Now, I let y equal t. Then x equal 6 minus 2t. And z equal 0. Can you see? This is the parametric form of the equation of a line. I can rewrite the parametric form as the vector equation of a line. It becomes xyz equal t. So z is always 0, y is t, and x is 6 minus 2. You can use lambda here instead of t if you prefer. So when k plus 2 is not 0, the two planes intersect along a line. And this is the equation of their line of intersection. Intersection along a line has infinitely many solutions as well. So now we have seen that the value of k completely changes the relationship between the two planes. In the first case, the planes are coincident. In another case, they intersect along a line. And we even found the parametric and vector equation of that line of intersection. And before we move on to part 3, here's the important thing. IB exam questions love to test these cases, and students often lose marks by mixing them up. So in part 3, I will give you a clean summary table and a final checklist so you can recognize these situations instantly in an exam. After the row operations, we focus on the second row of the matrix. That means this row. If k plus 2 is 0, that means k is negative 2 only. The second row of the matrix becomes 0, 0, 0, 0 because k plus 2 is 0. Type of planes. The two planes are coincident. The solution is a plane, and the equation of the plane is x plus 2y minus z equals to 6. The equation of the plane as the solution because the two planes coincident. Okay, so this is case number 1. So case number 2, k plus 2 is not 0. That means k is any value except negative 2. And the second row of the matrix is 0, 0, k plus 2, and 0. The two planes intersect. And the solution is a line. And the equation of the line of intersection is xyz equal 600 plus t negative 210. If this video helped you, don't forget to give us a like and share with your friends. If you have any question you wish to clarify, do leave us a comment. Your feedback is a motivation for CC Tuition to create more IB style related problems.